In this video, we're going to show multi-WAN link balancing feature, which is a very useful feature for a network to aggregate multiple internet links bandwidth and provide failover between different links. If you want to know more about this feature, you can always go to docs.ransnet.com and you search multi-WAN. And there's detailed documentation to explain how multi-WAN works. So in this lab, I have a HSA L2 with 2 SIM cards already slotted in. So these 2 SIM cards will be running active and already powered on. So once the devices are online, they will automatically register from mfusion. So I can use my orchestrator to manage the configuration. So I'll just import the device into the orchestrator. And based on the demo lab setup, I'm going to set up VLAN 10 and branch Wi-Fi. I've already configured the branch Wi-Fi in the global setting. So the branch Wi-Fi mapped to VLAN 10. So I'm just going to configure VLAN 10 on the HSA and attach the global Wi-Fi setting. And just to double check the WAN connections or the SIM connections are alive, you can click on the interface status to check the details. So the first SIM card is online. I get IP address. I can see the signal strength. I check the second SIM card. The second SIM card is online as well. Now I'm going to configure multi-WAN feature to enable active or link balancing. You can configure multiple combinations. So I'm just going to use a simple option now. So the metric is very important. The metric determines the priority of the link. So the lower the metric is, that means it's going to be an active one. So I'm just going to put 1 and you can enable tracking. For the start, I'm going to test each link speed first. So I'm going to enable the first SIM to be active and the second one to be standby. And enable tracking. Apply config. Okay, config push is successful. So you can view the multi-WAN status. Okay, at this stage, both links are online actively tracking. That means they are alive and they're detecting the link availability status. Because I set WAN 0, which is the first SIM card, to be lower metric, so you will be an active link. Now ready to do a speed test. Connecting to branch Wi-Fi, connected. Just to verify my IP address. So now I'm actually getting 187 and this is the IP address. Just to record it down. So I'm just going to do a speed test now. Okay, the speed test is about 18 meg download, 19 meg upload. So now I'm going to check SIM2. So what I'll do is I'll change the priority. And wait for the config push. Push is successful, and again we can verify the multi-WAN status. Now WAN 1, that is second SIM card, is active now. And if you go to the device to check my public IP, okay, my public IP is changed because I'm now on the second link, just to show the link difference. Okay, now we do a speed test. Okay, the second SIM seems to be slower. Okay, so we would make it active this time. We'll combine both links. And we can assign weight to different links because we're getting different speed. So this one is around 10, so you have to plus minus a little bit because this is a mobile connection. It's not 100% accurate. So 18, and also we have to assign them to have the same metric. That means same metric means we're going to distribute load to both links. Save. Okay, so once the config push is successful, again we verify the multi-WAN status. So now both are active, but they are carrying different weights. 35% of the traffic will go to second SIM card and 64% will go to the first SIM card because we have assigned weight because they have different speed. So the system will load balance the traffic across 2 links with different weightage. So now we are going to run a speed test again. So as you can see, we get pretty much a combined speed, about 30 meg download. 37 upload. So it's pretty much combining both links capacity. So we get a combined speed of both links. And just to take note, this is multi-WAN link balancing. That means we are load sharing the traffic across two different links, or rather at connection level. So that means the traffic, you will track the connection for each link. And as you can see, our speed test is doing multi-thread. Only multi-thread you can get an aggregated speed so that we can assign the connection to different links. If you run a single thread, the connection can only go through either link. So let's say now we're going to do a single thread test. We will not be able to get this kind of speed. So we can only get a speed of either link. We cannot get a combined aggregated speed for a single thread speed test, because for a single thread speed test we cannot load share the traffic across both links. We will have a separate video to cover WAN bonding. That means to combine link speed at layer 2 level so we can aggregate both link capacity even for a single thread connection.